PreCalc. Here we go with section 4. Determinant of a square matrix. Every square matrix can be associated with a real number called its determinant. I think we kind of looked at that earlier already. Determinants have many uses, and several will be discussed in this and the next section. Historically, the use of determinants arose from special number patterns that occur when systems of linear equations are solved. Okay, so we can look at the patterns here for two linear equations, a system of two linear equations. And if you didn't want to go through and do the substitution or elimination, okay, we got a pattern here that the solution will have the answers of x equals C1 times B2 minus C2 times B1 over A1 B2 minus A2 B1. And then y will equal that as long as the denominators don't equal 0. Note that the denominators of the two fractions are the same. This denominator is called the determinant of the coefficient matrix of the system. Okay, the difference of the diagonals. A1 times B2 minus A2 times B1 or B1 times A2, however you want to write it. The determinant of matrix A can also be denoted by vertical bars on both sides of a matrix, as indicated in the following diagram. Okay, so we can write it either DET parentheses A, or vertical bars around capital A, or vertical bars around the actual matrix written out. Okay, they are used interchangeably to represent the determinant of A. Although vertical bars are also used to denote absolute value of a real number, the context will show which use is intended. Okay, the convenient method for remembering the formula for a 2 by 2, which is what we've looked at already, is the difference of the diagonals. A1 B2 minus B1 A2. Okay, so let's work on finding the determinant of each. So difference in diagonals. 2 times 2 is 4 minus negative 3 times 1. So 4 minus negative 3, we should have 7. Minus negative turns into a plus. Okay, here we're going to have 4 minus 4 for 0. And then we're going to have 0 minus 3 halves times 2 is going to be 3 for a negative 3. In example 1, note that the determinant of a matrix can be positive, 0, or negative. They did a good job there shuffling it up to show you that it could come out as any of those three possibilities. Okay, coming up next, we have some brain-bending stuff. Okay, well, I suppose we got a sentence or two here to finish up. The determinant of a matrix, order 1 by 1, is defined simply as the entry of the matrix. Okay, there is no diagonals to do for a 1 by 1 square matrix, so if the matrix is just the number negative 2, the determinant is also negative 2. Okay, now we're going to get on to the good stuff. To define the determinant of a square matrix of order 3 by 3 or higher, it is convenient to introduce the concepts of minors and cofactors. Minors and cofactors of a square matrix. If A is a square matrix, the minor M sub ij of the entry A sub ij is the determinant of the matrix obtained by deleting the ith row in the jth column of A. The cofactor C I sub ij of the entry A sub ij is negative 1 to the power of I plus j times whatever your minor was. Okay, so they have the pattern over here for 3 by 3. So for this term, the first row, first column 1 plus 1 is 2. Negative 1 to the 2 power, to the second power, there's positive 1. So the sign would not change. So it doesn't necessarily mean plus, doesn't necessarily mean that it's positive. Plus just means that it stays the same. Okay? And then in this spot, first row, second column, so 1 plus 2 is going to be 3. Negative 1 to the third power is negative 1, which means that this one is going to switch. It's going to flip signs, switch signs. And that's at the end, okay? So for a 3 by 3, we are going to break it down into 9. I know, that's a lot. 9 little mini matrices, or minor matrices. And then we're going to do the determinant of all of those. Okay? So, minor 11. M11. We're going to delete the first row and the first column. Alright, I'm going to show some work here, I guess, for the first one, So we're going to delete the first row and the first column, so we're just looking at those 4 numbers. Negative 1, 2, 0, 1, right? Because we crossed off the first row and the first column. So we're working on those 4. Okay, so difference here of the diagonals. We're going to have negative 1 times 1, which is negative 1, minus 2 times 0, which is 0. We're going to have negative 1. Okay, M12, minor 1, 2. We're crossing off the first row and the second column. So we got 3, 4, 2, 1. That's kind of a tricky one. Okay, so we got 3 minus 8. Negative 3. And then M13. Okay, we're going to cross off the first row, third column. So we got those over here. 3, negative 1, 4, 0. So we got 0 minus negative 4. So 0 plus 4 then would make this be 4. Okay, so if you think you got the hang of that, go ahead and push pause and work on the next 2 rows on your own, and let's see what we get. Okay, welcome back. Let's look at that the 20s row. Okay, M21, we should have 2, 1, 0, 1. So we got 2 minus 0 for 2. M22, cross out the middle row and the middle column. We got 0, 1, 4, 1. So we had 0 minus 4 for a negative 4. And then M23, second row, third column. So we had 0, 2, 4, 0. So that's going to be 0 minus 8 for a negative 8. The 30s, third row, first column, so we got negative 1, 2, 0, 1. Third row, first column, 2, 1, negative 1, 2. That's better. Third row, first column, so there we are. It gets tricky. Get going too fast, your eyes will play tricks on you. So we got 4 minus negative 1 for a total of 5. 32, so we had 0, 3, 1, 2. 0 minus 3. And M33. Okay, we should have 0, 2, 3, negative 1. That's 0 minus 6. negative 6. Okay, there's all my minors. All right, now for cofactors, okay, we can just think about it here a little bit. Like we said before, it's negative 1 to the power of I plus j times your minor. So 1 plus 1 is 2, so negative 1 squared is 1, so that one stays the same. Because it's going to be 1 times negative 1 for negative 1. Okay, 1 plus 2 is 3, so negative 1 to the third power is negative 1 times our minor, negative 3, so negative 1 times negative 3, positive 3. And then 1 plus 3 is 4, negative 1 to the fourth power is 1, times our minor, 4, 1 times 4 is 4. So for 3 by 3, we can follow this pattern. Plus, minus, plus. Now, the plus doesn't mean positive. The plus just means stays the same. So stays, switches, stays. Switch, stay, switch. Stay, switch, stay. We're out of room over here, so let's go with C11 stays, so negative 1. C12 switches, so positive. What's this? 3 minus 8. Not negative 3, that's negative 5. Negative 5. So switches, that's going to be positive 5 now. And then C13, this one stays, so it's 4. Okay, 21 is going to switch. So basically, if the total of those two numbers is odd, it switches its sign. If it's even, it stays the same. So 21 is odd. This is going to switch to negative 2, stays the same. Negative 4, switches, positive 8. 31, C32, C33. So 3 plus 1 is 4. This one's going to stay. 32 is odd, so it switches. Negative 3 now is positive 3. And 3 plus 3 is 6, so this one stays at negative 6. So there's all our cofactors. Okay, now all of that stuff there, and we're going to find out that really we only need to do it for one row. It's good practice to be able to do it for all of them, do all 9 of them. Okay, really we only need to do it for one row or column. Okay. If A is a square matrix of order 2 by 2 or greater, the determinant of A is the sum of the entries in any row or column of A multiplied by their respective cofactors. Okay, for instance, expanding along the first row yields. Okay, so if it was a square one, like our 13, A11, your original number for the first row, first column. All right, so let's just take a look at, well, I guess they have it already. Do I want to give it away already? Well, let's just come down here. We're just going to add them all up. The term times its matching cofactor, and you add them all up. So if we were to go row 1, okay, we got 0 times its cofactor, negative 1, plus 2 times the cofactor of 5, plus 1 times the cofactor of 4. So that's 0. And 10. And 4 for a grand total of 14. Okay, let's try another one. I bet you it comes out to be 14. Let's try if we did row 2. I know we're kind of going to lose it on both. Can we keep it on the same screen here? So 3 times negative 2 plus negative 1 times negative 4 plus 2 times 8. So we got 3 times negative 2, that's negative 6, plus 4, plus 16. So negative 2 and 16 is 14. Let's do a column. column 3. So we got 1, 2, 1, and 4, 8, negative 1. So we got 1 times 4 plus 2 times 8 plus 1 times negative 6. So we have 4, 16, negative 6. There's 20 minus 6 is 14. Craziness. It works. Okay. So now that you know, you really only need to be able to do one full column or one full row of all that. Let's see what we can do. Okay, and then you also, without flipping back and forth too much here, remember that it goes plus, minus, for a 3 by 3, plus, minus, plus. Okay, well, let's put it over here. Plus, minus, plus, minus, plus, minus, plus, minus, plus. Remember, the pluses stay the same, not necessarily positive. They just stay the same, and the minuses change. Okay. If you think you got it down, you want to just try for 3 of them, go for it. All right, I'll give you a second here to push pause. Otherwise, I'm going to walk through row 2. Or row 1, excuse me. Okay, so I need 1, 1, M11, M12, and M13. So 1, 1, we cross out row 1, column 1, we have 5, 0, 4, 1. Okay, that's 5 minus 0 for 5. Okay, for 12, row 1, column 2, we cross out that and that. We have 3, 0, negative 1, 1. 3 minus 0 is 3. And then M13, 1, 3, so we have 3, 5, negative 1, 4. That's going to be 12 minus negative 5 for 17. Okay, those are my minors. Now my cofactors, C11, C12, C13. This one stays. This one changes. This one stays. Okay, and then now I take the cofactors times the actual terms and add them all up. So we got 3 times 5 plus 4 times negative 3, and then plus negative 2 times 17. 15, negative 8, negative 34. Not negative 8. 3 times negative 4, we got negative 12. Going too fast. Okay, so we got negative 46 and 15 for a negative 31 for our determinant. How about that? Okay. If you don't believe me, try a different one. Check it out. Try a different row. Try a different column even. Negative 31 is what we should be getting. All right, folks. Thanks a lot. Thanks for watching. Let me know if you have any questions and get started on that homework.